start with a simple scenario. Imagine your application is running on just one server. Now picture 100 users all sending requests at the exact same time. What happens? Every single request lines up, waiting for that one server to respond. As the queue grows, so does the waiting time for each user. This is where queuing theory comes into play, helping us understand and manage these waiting lines in technology. But what if we could do better? What if instead of one server, we had several and could share the load between them? That's where load balancers step in. With only one server, every incoming request has no choice but to wait its turn. As more requests pile up, the queue gets longer and users experience slower response times. This bottleneck can quickly become a major issue, especially as your application grows in popularity. The solution seems obvious: add more servers. But as soon as you do, a new challenge appears. How do you decide which server should handle each new request? This is not just a technical question, it's a queuing theory problem at its core. To the load balancer, a smart component that sits between your users and your servers. Every request from a client first arrives at the load balancer. Its job: decide which server should handle each request. The goal is to distribute requests efficiently, prevent any one server from becoming overloaded, and keep response times as low as possible. By doing this, load balancers help maximize resource utilization and keep your application running smoothly, even under heavy traffic. So how does a load balancer actually decide where to send each request? There are several algorithms it can use, each with its own strengths and weaknesses. The simplest is called round robin. Imagine you have 4 servers. The load balancer sends the first request to server 1, the second to server 2, and so on, looping back to server 1 after server 4. This method works well when all servers are equally powerful and requests are similar in size. See round robin in action. Request 1 goes to server 1, request 2 to server 2, request 3 to server 3, and so on. After the last server, the cycle repeats. This approach is simple and predictable, making it easy to implement. However, it assumes that all servers are equally capable and that each request takes about the same amount of time to process. But what happens if one server is slower or busier than the others? Problems arise when servers are not identical. For example, if server 2 is busy with a long-running request while server 3 is idle, round robin will still send the next request to server 2 just because it's next in line. This can lead to longer queues and increased waiting times on some servers, while others remain underused. Clearly, we need a smarter way to balance the load, especially as systems become more complex. A more intelligent approach is the least connections algorithm. Instead of simply taking turns, the load balancer checks which server currently has the fewest active connections and sends the new request there. This helps balance the workload more effectively, ensuring that no server is overwhelmed while others are idle. It's especially useful when requests vary in length or servers have different processing speeds. Modern load balancers offer even more sophisticated algorithms. Weighted round robin gives more powerful servers a larger share of the requests. Weighted least connections considers both server capacity and current load. Least response time picks the server that's currently responding the fastest. There's also IP hash, which ensures requests from the same client always go to the same server. Each method has its own use case, making load balancing a flexible and powerful tool. By distributing requests intelligently, load balancers help reduce waiting times, prevent overloads, and make the most of your server resources. Whether you're running a small app or a massive web service, understanding queuing theory and load balancing strategies is key to building fast, reliable systems. With the right approach, you can keep your users happy and your infrastructure running smoothly, no matter how much traffic comes your way.